Okay. So this assignment is in two parts. So there's the absolute part and then there's the systems of equations. So absolutes are what you started last week, and then that's it for the lesson. And that continues on into 30-1. So there's a whole kind of section about absolutes. So this is important. Okay. So I'm not going to glaze over it. There's a few things that you need to really take from it. And then it goes into systems of equations, which comes from 10C. And that's what this week's lessons are about. And you'll see that this assignment continues into next week. So you only have to do 3 questions today, but then you don't have to hand it in. And then once we're done the systems of equations, there's 2 lessons. So that'll be tomorrow's lesson and Thursday's lesson. Then on Monday next week, you'll have the next assignment, or the last 2 questions of the assignment due. So that's when you'll hand in all these parts. Got it? Okay, so let's go through this. So what you need to know about absolute values is that absolutes of negatives become positive. So negatives become positive within these kind of absolute lines. Positives don't change, and then zeros don't change as well. Okay, so it only affects negative answers. Negative answers flip to become positive answers. Yay, Brady. Okay, so our first question is similar to question number 1 in your assignment as well. So I'm going to go through these guys, and then hopefully you guys get the main idea once I do these questions. So for the first one, 1A, you can use your calculator, of course. So on your graphing calculator, you do have absolute brackets in there. So I'm going to show you where that is because it's going to be helpful for when you graph them. So if you go to your graphing calculator, so make sure you have a graphing calculator in front of you guys so you guys can see what buttons I'm pressing. For you guys, you're going to press math. So math. You're going to go to the right where it says number. So at the very top of the screen, you see NUM. So go to the right, highlight that. And once it's highlighted, you'll see ABS, abs. That's a short way of saying absolute value. So if you press that, then you can put absolutes around whatever you want. So that is one way to calculate it, is using that function in your calculator, or just using logic, of course. So for example, with absolute lines, you treat them like brackets. So I'm going to do what's inside the brackets first. Okay, so first I'm going to have -11. So I'm going to start with this first question. There's no absolutes within this part, so I'm going to do this first. So 2 negatives becomes positive. So the absolutes are not affecting it just yet. All I have to do is that so far. Okay, so 2 negatives just in regular rules becomes positive. And then you'll have 2 within absolute, and then the absolutes, -6 plus 11. So that'll be, what was it? 6, 7, 8, 9, 10, 11, 4. Okay, so that becomes +4. Now, nope, wrong. 5. There you go. My brain is not working. There you go. Okay, so once you evaluate what is within absolutes, then you just look at this part and say, well, what is the absolute of 5? A positive does not change, so it just becomes 2 multiplied by 5. So then you can just treat it like a regular bracket. 2 times 5 is 10, and that's your answer. Okay, and then you can even check with your graphing calculator. So I could put this same thing into my graphing calculator and see if it gives me that answer. So I'll prove that to you. Let me just remember this question. Give me 1 sec. I'm just writing it down so I don't forget it and have to refer to it again. That's how bad my short-term memory is. Okay, so in my graphing calculator, if you wanted to do this in a regular calculator, you would go 2, then you'd go math to number 1, okay? And then within the absolutes, you're going to go -6, subtract in brackets, regular brackets, -11, close those brackets, okay? And let's see if this works. And your answer is 10. So you get the exact same answer. So I'm just showing you that you can do this using that function for absolutes, or you can just do it using just your knowledge of absolutes. So you have two choices there. B, let's look at the next question where it says the absolute of negative 9.5. Anytime you have a negative in absolutes, it becomes positive. So negative 9.5 just becomes positive 9.5. And then subtract 12.3, a positive number within those two line brackets does not change. So I would just have to subtract 12.3. So that's how the absolutes go away. And then in your calculator, you're just going 9.5, subtract 12.3. My answer is negative 2.8. Okay, so you can get a negative answer as long as the absolute, whatever's inside those absolutes, becomes positive. Okay, so that's C, or that's B. Question C, they're saying 3 times the absolute of 1/2 would just be 3 times 1/2 because the positives do not change in the absolute. And then 5 times negative 3.3 over 4 becomes in brackets positive 3 over 4. So that's what you're essentially doing, is changing it to regular brackets once you kind of figure out what happens within those absolutes. Half of 3 would be 1.5 plus, you can have decimal values in this case here, so it's up to you. And then 5 times 3 divided by 4 would be plus 3.75. So I would put that into my calculator and get 5.25 as my answer. Okay, so you can write it as a decimal value or a fraction is what I'm saying there. Question number D. So I'm going to solve all of the inside part first and then just take the absolute of the final answer for question D. So we have 3 times negative 2 squared would be positive 4. And then positive 5 times negative 2 is negative 10 plus 7. And then so we have the absolute of 12 minus 10 plus 7. 12 minus 10 plus 7 is 9. So the absolute of 9 will still remain 9. Okay, so if it's a positive number, it does not change. And then for E, what you just want to do is kind of do each absolute one at a time and then add up all the answers or subtract the answers depending on what sign is in between. For example, negative 4 plus 13 is 9. The absolute of 9 won't change. It's still going to be 9. So I'll write that now, but I know it's going to be 9 in the end. And then I have in absolutes 6 plus 9. So you're going to have to change the two negatives to become positive. Subtract 8 minus 17 is negative 9 within those absolutes. And then positive, the absolute of negative 2 is positive 2. So I can already remove those absolutes because I've applied it already. Okay. And then now we have 9. The absolute of 9 is just positive 9 plus 6 plus 9 is 15. So we're adding 15. Then we're subtracting the absolute of negative 9, which is positive 9. And then we're adding 2. Okay. 9 plus 15 minus 9 plus 2 is equal to 17 as the final answer. Okay, so that's my final answer. So that's the first kind of question. I tried to pick like a bunch of examples that were similar to the one that you guys have in your assignments. Okay, so go into the comments and just let me know if you guys have any questions about this first question so far. So just remember that those absolute brackets are like regular brackets, but whatever's inside just becomes the positive of that answer, okay, if it's negative. Any issues, let me know in the chat. Just let me know if you have any questions or you're good to go to the next question. Good. Okay, Jonathan's good. Brady, how are you doing? And Emma, how are you guys doing? Brady's good. Perfect. Okay, so So let's go on to the second question. So this is where it goes into more of what you need to know for 30-1 and being able to graph an absolute function, okay? So what you want to do is you want to go to your graphing calculator and you want to start by graphing it, of course. And then from there, you can figure out the domain, the range, and then the y and x intercepts, okay? So step one is going into your calculator and graphing 2x minus 3 in absolutes. Okay, so go to y equals, clear whatever you have there. So remember the button that you want to use would be in math, number, and then absolutes. 2x, and I think it was like minus 3. 2x minus 3, yeah. 2x, subtract 3 within absolutes. Okay, so make sure you have that ABS in front, and that's how you know you're doing it properly. For this question, I'm going to use the standard window. So I'm going to go from -10. So most of these questions where you do have to graph will be the standard window. So you don't have to worry too much about figuring out where it's located. Okay, so when you look at the actual values before you put the absolutes around them, they are linear. This is a linear equation within absolutes. So normally linears will be like that straight diagonal line. In this case, it will be going up to the right. So when you graph it, what you guys want to kind of remember from this is that, let's say you have a linear equation and it looks something like this, okay? What's happening is this part that's negative, wherever y is negative, is not going to exist anymore because it's going to flip. It's going to become the reflection where now our new image is going to look like this. So I'm going to do it with another color so you guys can see. So this negative part is going to flip upwards to be like a reflection, and then this part that's positive remains the same, okay? So if the y value is positive, it remains the same, it does not move. But then this guy becomes that. It flips so that the y value becomes positive y's, okay? So that's what you need to know about this graph. So let's go back to my graphing calculator and then graph it. Okay, so in this case, when you have a linear equation, you should be getting like a V shape if you're doing it properly, okay? And then what you want to do is sketch this. You can go to second graph, and then you can plot like a few of these table of values points on your actual graph here. So I'm going to do that. Another thing you could do is, this is kind of like how it's useful too. So I'm kind of doing B here. This is useful for 30-1 is if you have your equation, we know that this is a linear equation where the y-intercept is -3 normally, 1, 2, 3, -3. And the slope is 2/1, right? So 2/1 means that's your rise over your run. So you're going 2 up, 1 to the right. 2 up, 1 to the right. So I'm kind of using that picture to help me sketch before the absolute occurs. So the linear part, okay? So this is kind of trying to show you how understanding is built from this. So if this is my original graph, all you have to do to make your absolute graph is this part stays the same. So I'm going to redraw this part because it's positive. The x-intercept remains the same. But then this point, do you see how it's, this point right here, do you see how it's one distance away from your x-axis? That means above it, it's going to be one distance away. So that's the reflection of it across the mirror line. And then this next point here, do you guys see how it's 3 distances away from the x-axis? So that means it's going to be 3 above your x-axis. Okay, so those are reflection lines. And then this one here, this last part, I'm just going to mark it off. That point is 1, 2, 3, 4, 5. This distance right here is 5 distances away from your x-axis. So that means it should be above that x-axis 5 distances away. So 1, 2, 3, 4, 5. And now I get my V shape. Okay. Now, the easy way, of course, guys, is just going to your table of values and just plotting these points. I kind of showed you the, just to kind of build some understanding for 30-1 is what we're actually doing here, is we're reflecting it, okay? So that would be a good sketch for B. So full marks there if you do something like that. The y-intercept and x-intercept, you can use your graphing calculator or you can do it algebraically. So algebraically is we have y equals the absolute of 2x minus 3. So this is question A. If you want to find the y-intercept, set x equal to 0. So y equals 2 multiplied by 0 minus 3. And then so the absolute of 2 times 0 minus 3 would have been negative 3, but within absolutes, negative 3 becomes positive 3. So I know that my y-intercept is positive 3, and look at my picture. It actually is. The y-intercept is, the coordinates are 0, 3, okay? So that's what they're asking for, is the y-intercept equals, in this case, positive 3. So that's one answer. For the x-intercept, set your y equal to 0. So that means 0 equals absolute of 2x minus 3. This, I wouldn't do it this way because I haven't shown you how to do that last lesson just yet. Once you do question number 3, then you can use that method to solve this. But in the meantime, what I would just do is go to your graphing calculator and go second trace. You can find your 0 of your original image. Actually, never mind. A faster way, guys, is take off the absolutes. The reason being is, you guys, if you look at your image, your original graph, your original linear equation and your absolute will have the same x-intercept. So because they have the exact same x-intercept, if you just solve for this, it'll have the same x-intercept. So if you move negative 3 to the other side, 0 plus 3 is 3. And then 2x, if you divide by 2, that means your x-intercept, oh, should be 2. Your x-intercept should be equal to 1.5, okay? So that is just showing you that if you use the equation without those absolute lines, it will have the same x-intercept in 20-1. Next year, it'll be slightly different, but once you learn this method right here, question number 3's method, you can use that for what we just did, okay? Okay, so recap. Y-intercept, set x to 0. You can do it that way. And then for x-intercept, set the linear equation without the absolute lines equal to 0, the y value, and then solve for x. Okay? So that is your x and your y-intercept. Domain, let's do domain. So the domain and range of the absolute value, the domain is always going to be XER in these cases. There's no situation attached to it. So you would say x such that x is an element of the real numbers. Okay, so domain, it extends forever left and right. So x such that x is an element of real numbers. Okay, so all absolutes will have that in common unless they say this is a situation where x is time. Okay, so that might change it, but if it's just an equation, no situation, no real life situation attached to it, XER. Range. Look at the value. I'm looking at the orange graph only. The graph goes from 0 for y and above. Okay, so it touches the x-axis and then shoots straight up in that V shape. So we would say y is greater than and equal to 0 because it does touch the x-axis, and then we would say YER. Okay, so most graphs that are absolutes, if the entire thing is within absolutes, it's pretty much always going to be 0 and up. If the graph did this, then yes, that would actually change the situation, right? So keep that in mind. So that is your range. Now there's one more part to it. This next part I'm trying to remember. I don't think there's anything in 30-1 about piecewise function, but it comes back in calculus. So if you are going and planning on going into calculus, then you'll see piecewise functions come up a lot, okay? The reason being is piecewise functions are really applicable in real life scenarios because let's say you have, I'm going to show you an example, guys. Let's say you have a graph like this with this. This could be like the stock market, right? So for example, like the price of a stock goes down and then it kind of gradually increases and then goes down again. So this is kind of what a stock looks like. What they do in real life, like what they do outside of like a math class, is they divide a graph and they say, well, this part right here is represented by a quadratic equation. This part right here looks like it's linear. So if I put those two pieces together, a quadratic equation with a linear equation, it will now represent what graph I have so that I can actually graph it in my calculator, okay? So that's what you guys do. That's what, if you had done your final project, that Desmos project, it would have been like that because you're kind of piecing together different equations to make your final continuous image. And that's what a piecewise function really does. It's really, if you go into math, there's so much usage for this. So it's a really important concept, not so much for 30-1 math, but for calculus and then further if you do plan on going into calculus and above, okay? So I love them. Like, I think this is a cool thing, a cool idea, okay? So for piecewise functions, what you want to do is you want to start by sketching the linear image that you, you want to start by sketching that V shape, okay? So the absolute. So we know that we're sketching 2x minus 3 in our graphing calculator. We already did that, right? So I'm just gonna kind of casually draw what that looks like. Now, what is really, really important right now is to find always your x-intercept. We know that our x-intercept was 3/2, which is equal to 1.5. So we can write it as 3/2 or 1.5, your choice, okay? Now, that graph, if you guys look at it, that x-intercept kind of divides your graph into two sections, okay? So your graph is being divided into two linear equations. There is one linear equation being formed right here. So this is one linear equation here. And then this is another linear equation being formed on the left of that x-intercept line, okay? So what we want to do is an absolute value is always made up of two equations. One being a negative version of the graph and the second being a positive version of the graph. So to write a piecewise function, you do this. You take what's inside the absolutes and you write it exactly how you see it. So that's one version of it. The other version of it is you take that and you just distribute a negative to all the values inside that bracket because that's the opposite of it, right? So the opposite graph of 2x minus 3 would have looked like this. Minus 2x plus 3. So the signs will change. Now, what I want to prove to you guys is this. If I go to my graphing calculator, I'm going to now graph 2x minus 3. Okay, so I already have the original one. And now right underneath it, I'm going to graph 2x minus 3 in my graphing calculator. Do you guys see how this red piece right here goes over the blue? This part right here, from here and going to the right, all this part is identical to the blue, but it stops right at that x-intercept. So what I'm saying is I need to cut this graph so that it is only the blue part. So for my first equation, I'm saying I want the part of the graph of 2x minus 3 where it is x is greater than, because it's to the left, it's the right. So I wanted this piece right here being recreated, and that's to the right of the x-intercept. So that means to the right of the x-intercept. So x is greater than 1.5 or 3/2. So this is like a cut. I'm cutting my graph to give me this purple line right there. And then the next equation, I'm going to go back to my graphing calculator, and I'm going to do the negative version of that equation, negative 2x plus 3. If you guys look, now this goes over the left side of that x-intercept. Okay, so this point right here, if you go, I want all this. If I move my cursor, oops. I just want to move that guy, nothing else. Okay, so where that dot is, if I'm on the actual x-intercept, I want to the left. I want the piece of it that is the left of that point right there, because that's going to go over top of my blue piece. So if I want the left of it, I would say x is less than 1.5, okay? And then there's one more step. All you have to do is put an equal sign either for the top one or the bottom one, okay? That's it. It doesn't matter which one you put the equal sign with, but as long as you only put it to one value, because you do want to include that x-intercept without going on top of it. So you don't want to you don't want to have an equal sign for both, because that means there's a point over a point, and that's not okay. So you only want that equal sign to go on one of these inequalities, okay? But this is what a piecewise function is right there. That's the answer for what a piecewise function is. I'm saying I need this piece and this piece to make my V shape. So that's, for me, I feel like that could blow your mind. It's a little like, there's a lot to it, right? So I'm going to do another example just like that with the quadratics. And if you still don't understand, I can find another example and show you as well, because this one is the most complicated kind of like reaching idea I find when it comes to 20-1. So it's a big concept to kind of wrap your head around, okay? So that is the piecewise function for this guy. So we will go on to the next question, but you'll see that the same questions will come up again, okay? So step one, we want to graph what this guy looks like. I'm just going to write it down so I don't forget what it is. Okay, so go to your graphing calculator. And then put that in exactly how you guys have it. So you want to go math to the right, number, absolutes. Okay. And then within the absolutes, you're going -3 bracket, x plus 2. So this is a quadratic that is being taken the absolute value for, right? So what you need to remember is that all the y's that are negative are just becoming positive for this image. And then when I graph it, the standard window, oh, actually, I don't like this one. I think I'm going to change this because this is going to be, I don't like this guy that I made up. No, I want to go down actually. I'm going to adjust this, guys. I don't like this question because it doesn't do what I want it to do. There you go. Okay, this is what I want. So I'm going to adjust the question to look like that. So small adjustment, but now it's going to be more accurate to what you guys might find in your assignment. Okay. So once I graph it, this is the absolute, okay? So the reason being is that normally this is supposed to be a downward facing parabola, but this arm right here, this arm that you guys see right there, has flipped upwards so that it is positive. Same thing here, this arm right here has flipped upwards. Okay, so it used to be, I'll show you what the graph used to be like. So this is the original quadratic function before putting on absolutes. And so do you guys see how that little hump didn't change? That's where the blue and the red intersect. But then these red legs that are y is negative, they flipped upwards. Okay, so that's why we need to graph it that way. Okay, now with this in mind, I'll show you graphically how to find that y-intercept. Okay, so I'm just going to clear this, even though I do need it eventually. To find your y-intercept, you can go trace, 0, enter on your calculators. So trace, 0, enter. I have to do it a different way in my calculator because it doesn't allow me to do it, but you guys just have to press trace, 0, enter. And so your y-intercept should be 8. So I'll write those steps down. So this is for the intercepts. I did trace. I put x equals 0, and then I pressed enter in my calculator, and I got that the value for y was equal to 8. Okay? So that's going to help me for my sketch, because when I have my graph, I know my vertex occurs at -2 and +4. That's the vertex of the graph. So that way you can actually plot it, because that doesn't change. When the y coordinate is positive, those remain the same in absolute functions. So -2 and +4, 1, 2, 3, 4, plot that right there. And then plot your y-intercept of 8, 1, 2, 3, 4, 5, 6, 7, 8. So far I have that. The other thing that is really crucial, guys, is your x-intercepts. So we need the x-intercept. And I usually like to, for that, I usually like to look at the original graph before it was an absolute, okay? Because then it doesn't give me issues. So if you want to do this graphically, put in the function without absolutes. So this is what it looked like. And then you can go second trace, number 2, which is zeros. Go to the left side of that x-intercept, press enter. Right side of that x-intercept, press enter, and enter again. And we know that one of them is -3.155. And then we need the other one as well. So you would repeat that step by going second trace, number 2, go to the left side of that x-intercept, enter, right side of that x-intercept, enter, and enter again, 0.845. And then you can plot those. So this really gives you a nice image of what you can expect for the sketch. Okay, so you're answering the questions while doing the sketch. Okay, so why do I have that? It should be negative, I believe, right? Yeah, negative. That makes more sense. So that should be a negative 0.845. So when I sketch that, it should be about here. Go back. And then you just have to connect these. So we know that the graph is kind of going to be like a W shape with that upside down U going through it. And then you just want to put arrows on each side. Okay, so that's my sketch. What I'm labeling is my x-intercepts, because that's going to be helpful for my piecewise function. Okay, so far we did our intercepts, we sketched it, and now we're doing the domain and range. Make sure you always label your x and y axis, and then put the scale as well when you're doing this. There you go. Domain. Domain is just like a linear function. It's going to be XER. X such that X is an element of the real numbers. Range. You'd say Y such that Y is greater than or equal to 0, YER. So identical to the previous question, it's going to be XER and then Y is 0 and above. Okay. The piecewise function. So I know that's the tricky part. So step one, guys, is we go Y equals, and we have this kind of big curly bracket to say that Y is equal to 2 parts. One of the parts is you remove the absolute brackets and do not change a single thing. Okay, so I've removed those absolutes, and that's my first version of the calculator, or the first version of the equation that is making up this image right here. Okay. But in order to make up the other image, I have to do the negative version of it, meaning distribute a negative. And how does that affect the actual picture? Well, it will affect this sign and this sign only, okay? Because when you affect -3, it already does that because these guys are multiplying. So you do not have to change this sign in order to make it the negative version of it, okay? So the opposite of this will be +3, because a negative times a negative becomes positive. X plus 2 squared will not change, but then this minus, or this +4 becomes then -4. So that's what you need to remember about vertex form, is that the A value and the Q value are only affected when you distribute a negative in there, okay? So once you have these two pieces, we need to figure out where should we cut the graph so that we get this image right above here, this kind of like W shape, whatever you guys want to call it, okay? So we can start in our calculator by putting in the original one, the -3 x plus 2 squared plus 4, which we already have, but I do want to include still that absolute, just to show you which parts go on top of each other, okay? So we want the part that goes on top of the absolute. So math, number, absolute, -3 x plus 2 squared plus 4, okay? Now, if you look at it, do you guys see how it's the hump? This part from this x-intercept, so I'm just going to put, so the right of this x-intercept to the left of this x-intercept is what I need in order to make this, I wish I could like show you what my finger's doing, to make this piece right here. So do you see where I'm touching? This is where they this is where they kind of intersect and go on top of each other. So I need to kind of copy this, okay? So for the first equation, this in-between part is represented by this always. X is greater than -3.155, but less than the next x-intercept, which is 0.845. So whenever you say the -3.15, so x is greater than that, that means that you're looking at the right of this number. If you're looking at the right of this number, you use this symbol. And then it has to be on the left side of that x value. And then here, this just means that you're on the left of this value right there. Okay, so my x is in between those two x-intercepts, and that's why x is in between. It's in the middle, okay? So that's how we show the first one, okay? The next one, if I go to my graphing calculator, now I'm going to sketch the negative version of that. So go to this equation right here, and then I'm going to delete that negative symbol. So I'm going to delete the negative symbol, and I'm going to change this positive symbol to subtraction. So the positive became subtraction, the adding became subtraction. And when I graph it, do you guys see how this is now intersecting, right? Only these two legs. These are two separate legs. So I want to take that left leg and then that right leg and copy them onto my actual image. So how we do that is we say that for this leg right here, I need to the left of that x-intercept. So I would say x is less than negative 3.155. Okay, so this means I want the left of this x-intercept. And then I also want this piece right here to make up my kind of W shape. And I'm going to say x is greater than that x-intercept, which is, we know is negative 0.845. Okay. So that, I'm almost there. There's one more thing you have to do is you need to put an equal sign to include the x-intercept. So that way it is continuous. It's a continuous graph and not just chunks, okay? So it doesn't matter which one you put it on, either the top level or the bottom equation, as long as you do it to each x-intercept, okay? So the x-intercepts need to be included. And that would be my final answer, okay? You don't have to include this left value, guys, or write that in. You just have to write this out. Okay, so if you go to Desmos, you can actually check to see if this works. So I'm going to actually show you that this is how you know this is how you can check your answer. So I'm going to go now to Desmos. I took a picture of it so then I don't forget. Where's my Desmos? There it is. Okay. So I'm going to put in exactly what I just did. I'm going to put in my answer that I wrote for the piecewise function, negative 3, x plus 1, x plus 2, plus 4. And then beside it, I need to do the cutting, right? So I have to, let's see if I can do this. Comma, I think I can do it that way. Negative 3.155, I'm just writing in my answer here. Because Desmos lets you cut the graph according to what you think is going to happen. So this is your way of checking your answer, guys. I do need to put in brace brackets, so let me see if I can find those. No. I think I have to put it inside. Here, let's try this. Oh, there you guys. Okay. Negative 3. And then curly brackets. Okay, so you're doing the function, and then within curly brackets, you're putting kind of like your domain that you're cutting it along. So negative 3.155, and then x negative 0.845. You guys see how I only now got the hump? And now I would put in the next one. So I know this is extra work, but this is how you can know that you're like 100% doing it properly. So this is your check that you can do using your graphing calculator or using Desmos. So here I would put x is less than negative 3.155. There you go. Do you see how it's starting to look like that W kind of U shape, whatever you guys want to call it? And then outside, make another curly bracket. You want to include another curly bracket for the other one. And x is greater than negative 0.845. Where are you? I might have to do that for as a separate piece though. Let's try that again. So there's one of the cuts. Actually, I feel like I should be able to do it here. There you go. Okay, I just put a comma in between them. That's it. So I put a comma in between it, and then, as you can see, those two equations made my single absolute picture. Okay, so this is how you create a picture that matches the absolute without using that function of the absolute. Okay, so that is my check, is putting this into my graphing calculator with the kind of curly brackets around your domain that you're cutting your graphic along. Okay, so I find that's like the crazy idea that you have to wrap your head around. The last one, I love these. These ones aren't hard, so it's just number 2 that you might struggle with. But if you need more examples, talk to me about that, and I can definitely try to explain it in other terms. But you can also YouTube videos and just put in piecewise functions and then see how other people say it as well. Okay. So the last example that we're going through is number 3. They want us to do this algebraically, and then they want us to verify. So what you have to do is you have to do 2 cases. Case 1, case 2. Okay, so that's how you start by solving an absolute. Case 1 is where you remove the absolutes and don't change anything. So it's kind of like what you're doing with the piecewise function. Remove the absolutes on the left-hand side and then keep everything else the same. That's like the positive version of the equation. Positives don't change anything, okay? And then the negative version of the equation is where you remove the absolutes, and then just like in the previous piecewise function, the -6 became +6. The x plus 2 squared is not affected, and then instead of +3, we have -3. The 3 on the right does not change because that was not an absolute. So only what is within absolutes is being affected. Okay, so those are case 1, case 2. And now you solve it like a regular question. Okay, so step 1, to solve for x, I would subtract 3 on both sides. So 3 minus 3 is 0. On case 2, I'm kind of doing them at the same time. You're going to add 3 on both sides. So those will cross off, and then you get 6. Now you're going to divide both sides by your a value. Divide this side by 6, this side by 6. That becomes then x plus 2 squared. This is 0 divided by -6 is 0. X plus 2 squared, 6 divided by 6 is 1. And then you just want to square root the values that you get to get rid of that square value. Okay, so square root both sides, you get x plus 2 now is equal to 0. When you square root 0, you get 0. Be careful with a value that is not 0, because if you square root 1, you should actually get positive and -1. So you're going to miss answers if you don't put positive and negative when you square root a value. 0 is the only exception to that rule, is when you square root 0, you don't get positive negatives, okay? But every other case, make sure you include both of those symbols. And then finally, subtract 2 on both sides to get x by itself. Subtract 2, subtract 2. So that means x equals 0 minus 2 is -2, so that's one possible solution. And then x equals, we have 2 possibilities here, because you kind of have to do this one, and then you have to look at that guy right there. So +1 minus 2 would be -1. And then -1 minus 2 would be -3. So you have all these answers that you need to confirm. Okay, so now we're going to check our answer. To check our answer, you're going to plug it back into the original question to see if the left side actually does equal 3. If it does, you're good. Okay, if it doesn't equal 3, then that means those are called extraneous solutions. Okay, so this is our verifying. Verifying is you're plugging in -6 instead of x, you're putting -2 plus 2 squared plus 3. This whole thing is 0, right? And 0 squared is 0. 0, let me move up actually. 0 times -6 is 0. So this whole thing becomes 0, leaving you with +3. That means the left side is equal to 3 and our right side is equal to 3. And that means that -2 is a solution. Let's then plug in -1. So we're going to go -6 in brackets, -1 plus 2 squared plus 3 within absolute is equal to 3. Okay, so that's what we're trying to confirm. So first I'm going to work with the brackets inside. So -1 plus 2 is 1. And then we have 1 squared is 1. -6 times 1 is -6. -6 plus 3 is -3. And then the absolute of -3 is actually 3. So left side does equal right side. So that means that -1 is a solution. And then lastly, you would confirm that -3 is a solution by plugging that in. Okay, so you would go -6, -3 plus 2 squared plus 3 in absolutes, is it equal to 3? So -6, -1 squared plus 3, is it equal to 3? And then -1 squared is 1, -6 times 1 is -6, and then -6 plus 3, it's the same as the previous case. It will equal 3. So left side will equal 3 and right side will equal 3, which means that this is a solution. Okay, so verifying, plug it in, check if left side equals right side. And then you can even confirm that this was all good. So another thing that you can do is, I'm just going to take a picture of this again. So this is it. This is like all you have to do for question number 3. But if you go to your graphing calculator, you can see if they're all solutions really quickly by graphing it. Whenever you do the graphing technique for solving, you just have to put the left side of your equation into y1. So I'd go math, number, absolutes, -6 bracket, x plus 2 squared plus 3. And then the y2 is the right side of your equation, which our right side is equal to 3. Then you would graph it. And then as you can see, it's where the two graphs intersect that are your solutions. If I find that intersection, this one here and this one here, it should match what I just found algebraically. Okay, so there's 3 solutions and they each match your answers for what you did algebraically. So that would be a quick confirmation to figure out what your solution is. Okay. So that is it. So like I said, the tricky part might be the piecewise function, but you can definitely message me and say, hey, like I need another example, and I can definitely do that for you. So question 1 shouldn't be too hard, I hope. Question 2, piecewise function. That will be your one thing that you kind of have to wrap your brain about. And then question 3, you just have to do case 1, case 2, and then solve like a regular quadratic equation, like solve for x. That's it. Once you isolate for x, check your answer. And those are the 3 questions that you want to work on today. And then next week on Monday, you'll be assigned question 4 and 5, and we'll go through those questions before you start, and they don't take up that much time. So if you get questions 1 to 3 done, then that's it. Like it gets easier from there. Okay. The nice thing, guys, is that there's not much left. If you guys can like push through, I know that it's definitely hard with the weather getting hopefully warmer. There's only going to be, after this assignment, there's only 2 more assignments left, done, and that's it. So after this one is completed, 2 more. That's the rest of the year from what I have planned. Okay. So hopefully you guys will survive. Okay. But don't forget to message me. If you have handed in your rational assignment, you guys are good to go, unless you want some additional questions shown, let me know. But if you need help right now with your rational one, because there's a few people still missing their rational one that haven't handed in, please stay online and ask me questions. So go onto the chat and let me know which questions you're struggling with the rationals. Okay. Any questions about these ones that I did? Are you guys okay? You guys need an additional one for a piecewise function? Brady, you're okay? Brady, do you need help with your rational? You sure? Okay. And then Jonathan, you're good? Okay. Brady, just message me if you do have questions. Emma, you're okay? Perfect. Okay. Thank you guys for joining me. I really appreciate it. I was like, where are my students? Okay. So I'm glad that you guys came online to go through this with me. And I hope that you're not struggling too much with the material. But if you are, just reach out. Okay. Don't forget that I am here. Okay. So I'll help you and do whatever I can to make it a little bit more smoother, and just keep your eye on the prize, meaning that once you get this one done, 2 more, and then you can relax with math and then not have to worry, hopefully. Okay. So thanks for joining me, guys. See you guys soon. Enjoy the rest of the week. There's only 2 short videos, the 8.1, 8.2 for this week, so it's going to be nice and short, okay? Have a good one. Thanks, guys. See you guys.